Markup, discount, and sales tax. In this problem, we're trying to find the sales tax. That means, or the total price, including the tax. So we need both the sale price of the boots and we need to add that sales tax to the cost of the price of the boots. First, we have a 40% discount. That means we have a sale price. And our sale price, if we use the formula of our original price or retail price, and we subtract our discount. Our discount is going to be our percent, the percent of our discount times our retail price. So you're going to do a little side work to find that amount. So our retail price is $95. And we multiply to our discount percent. So we change our percent into a decimal, 0.40. And percents are kind of easy. Just think about dollars, and we're working with dollars, so we want to turn these into a decimal. And so if we multiply 95 times 0.40, we would get $38. Because we have two places behind the decimal, so we have $38. So let's substitute in this is our discounted price. So we're going to subtract $38 from our retail price of $95. And that will give us our sale price. So if we subtract 95 from 38, we get $57. We're not quite done because we have to include our sales tax to get our total price. So our total price is going to be the $57, and we're going to add our tax. So our total price is going to be our sales price plus our tax. And our tax is going to be 8% times our sales price. So if we do a little side work, our sales price was $57 and our tax is 8%. So we're going to write 0.08 and multiply that to 57. And if you do your work, you should get $4.56. So our price for all the items is $57 plus $4.56. We do a little side work here. We get 57 plus 456. And we should get $61.56. So our answer is C. Moving down to exponent rules, which is equivalent. Our base for each of our powers is -2. And then since we have a quotient, remember a quotient is in a ratio form or a fraction. And so we're going to use the quotient rule, which means we're going to subtract exponents. So we're going to do 5 minus 7. So we keep the base, subtract the exponents. You should get -2 to the negative second. And we have a problem here. We have a negative exponent still. We don't like negative exponents. We have to turn it to a positive exponent. And if you see in our multiple choice answers, we only have positive exponents. So our rule for positive exponents, we can turn that negative 2 into a ratio over 1. Then we're going to take the exponent, turn it positive, and take all of that and send it underneath. Take the whole thing, send it to the other side of the ratio. And that would make it 1 over negative 2 to the positive 2. And our answer choice for that would be A. For number 7, we're dealing with the same concept that we just finished out. We have another negative exponent. So all we do is turn that, so if we have negative 2 to the third, turn that exponent to positive and send it to the other side of the ratio to get 2 to the third. Now we don't quite have our answer choices in powers, so we need to evaluate that. 2 times 2 times 2, so we got 2 to the third is the same as 2 times 2 times 2, which equals 8. So our final answer equals 1/8. And that gives us our answer choice of D. Let's move on down to the graphs. Now we have a U-shaped curve. That tells us we have an x to the second, or x squared type graph. These are also called quadratics. And when you have a U-shaped curve, if it's smiley face, if it's a U, it looks like a U or it looks like a smile, you're going to have positive values in front of x. In this graph, we notice that we have a frown. And so we know that it's going to be a negative number in front of our x squared. So usually we have A to represent the number in front of our x, it represents our coefficient in front of x squared. And so if we have a negative value in front, in this case it's a negative 1, and our only answer choice in this graph is that it's a negative, is A. If you had a smiley face, or if you had a U-shaped curve, positive values, your numbers in front of your A will show how quickly you're growing. So the bigger the number, the skinnier the U is, because it's climbing fast. If A is a fraction, if you have a fraction in front of X, it's going to grow slowly. So you're going to have a really wide U or a wide smile because it's growing slowly. Let's look at 10. The graph that represents Mrs. Downey's profit and loss statement. So we can see that it's going down. It's a negative slope. So for last year's holding and outcome enterprise, how much did Mrs. Downey lose for every dollar that she invested? So all we're doing here is we're looking for the slope, the change of y over the change of x. So if we take a point here where we have negative 4 and 5, and we're just going to move to 10 and 8. we're going to move down 4 and to the right 5 units. So we did down 4 over 5. And since all our answer choices in dollar amounts, we're going to turn this ratio into a decimal. So you're just going to divide 5 into 4. Remember, the top number goes inside. And if we do that, we should get 80 cents. So our answer is C. So our change is 80 cents.